The question says that f is differentiable and f prime is given. Find the interval on which f is increasing. So remember that we have tests for increasing, decreasing functions. What does it say? It says, first of all, this only works for the functions which are differentiable. So let f be differentiable on an open interval, like a to b. Then if f prime of x is positive on a b, then f is increasing on AB. So function being increasing is equivalent, or not equivalent, is a result of f prime being positive. And f prime being negative on all x's on the interval AB, we can conclude that f is decreasing on A. So increasing, decreasing is an important property, but finding that without this tool is not easy. You have to know this tool, and this will give you one easy way. Just differentiate and then find where the function is positive and where it is negative. So in this question, f is not given, f prime is given. So it means that what we go and find where f prime x is positive. So we want to find where, or for what values of x, f prime x is positive. Okay? And solving inequalities like this, always, there is a universal way to solve inequalities like this by finding the sign table. So we have to find the sign table of f prime. What we do is we set f prime x equal to 0. So it is 5x 4 minus 2x squared, to the power 5, 6x minus 3 squared equal to 0. And these are different factors of f prime. If three numbers are multiplied and you get 0, one of these guys must be equal to 0. It means that either 5x must be equal to 0, or 4 minus 2x to the power 5 must be equal to 0, or 6x minus 3 squared must be equal to 0. And from that, you can see that that means x is equal to 0. That means that 4 minus 2x is equal to 0, which implies that x must be equal to 2. From this one, this means that 6x minus 3 must be equal to 0, and that means that x must be equal to 1 over 2. Okay, we found where the function is positive in f prime, basically. Then we put them in order here. This is the table. So 0 first, then half, then 2. And we know that at these values, the f prime, the function whose sign table we are trying to find, are going to be 0. Now, we want to see if you have found all the zeros of the function, what you need to see what kind of sign that function has in those intervals. This is specifically for continuous functions. What you need to do is just evaluate the function in some values. For example, here you take 3, here take 1, here take, say, 1 over 4, and here take negative 1. For example, let's just check the negative 1, f prime. Oh, I will check it here. F prime at negative 1 is 5 times negative 1, 4 minus 2 times negative 1 to the power 5, and 6 times negative 1 minus 3 to the power 2. One thing, important thing here is that when you see square or any even power, no matter what is inside, it's going to be positive. If it is not zero, it's going to be positive. Here, this is 6 to the power 5. This is going to be positive number as well. But this guy here, this is negative. So the sign of f prime on that interval is going to be zero, negative. How about at f prime at 1 over 4? You just evaluate again. This part is positive, and then 4 minus 2 times 1 over 4. This is also positive, and then 6 times 1 over 4 minus 3 to the power 2. This is always positive, positive, positive. Everything is positive. If you continue working like that, what you will notice, if you evaluate the function at 1, what you will notice that that is going to be positive from 1 over 2 to 2 and negative. Very nice. So by doing this, finding this table, sign table, you have been able to find where the function is positive, f prime is positive, and where it is negative. Now it's time to use increasing decreasing test. If f is negative on an interval, f prime is negative on an interval, then f is going to be decreasing. If it is positive, it's going to be increasing, and similarly here. So right away you notice that f is increasing, it's an increasing function on 0 to half and half to 2. So basically, the test tells us it will be increasing on this whole 2 intervals. But if you note, these 2 intervals are basically from 0 up to 2, but we excluded 1 over 2 so far. Here is a trick. If you see that 2 intervals are closed like that, and the function is continuous at that middle point, or the point that you excluded, continuous here. This function is a polynomial, it's continuous everywhere. Then you can rewrite that fact and write this f is increasing on the whole interval 0 to 2. So f is increasing here. And while similarly, f is in decreasing from negative infinity to 0 and on 2 to plus infinity. So this way we have used the increasing decreasing test. We didn't know what is f prime was given, and that way we were able to find the interval on which the function is increasing.